In the world of engineering, precision is absolutely everything. But what happens when the very system for managing an engineer's education is, well, imprecise? We're talking budget blowouts, compliance headaches, even audit failures. Today, we're going to dive into a really groundbreaking solution out of South Africa that uses code to make sure every single dollar and every hour of technical training adds up perfectly.
All right, so here's our game plan. First, we'll pinpoint the exact gap in the system that's causing all these problems. Then, we'll meet the brain and the muscle designed to fix it. After that, we're going to look at the actual code that makes it all compliant, check out the pretty staggering test results, and finally, wrap up with how this could completely reshape the future of engineering management.
So this really gets to the core of the problem, right? In a field as critical as engineering, you just can't afford to guess. You can't estimate a student's qualifications or a project's budget. You need a system that's airtight, one that tracks, validates, and guarantees that every minute of learning and every penny spent is perfectly accounted for and compliant.
Our story kicks off inside South Africa's technical colleges. Now, these are the places training the next generation of engineers. You know, the people who are literally going to build our future. But they're stuck operating in a super high-stakes environment where money is tight and the threat of a financial audit is always hanging over their heads.
The real problem here is something the research calls the human calculation gap, and it's a big one. Because everything is done manually, you get this massive disconnect between what's taught in the classroom and how the finances work in the real world. You've got crucial tax incentives for R&D just getting lost in the shuffle. It's a recipe for disaster, and it essentially means the bridge to the future is being built on a very shaky foundation.
Okay, so how do you fix this? Well, enter the LAIS, which stands for Logogram Algorithm Integration Suite. This is the hero of our story. It's a system designed from the ground up to build a solid, reliable bridge over that gap between educational theory and real-world financial law.
So how does this thing actually work? Well, the idea behind it is incredibly smart, but also beautifully simple. You can see it's built on two parts that work together: the logogram, which acts as the brain, and the algogram, which is all the muscle. Let's take a closer look at what each one does. First up, you've got the logogram. The easiest way to think about this is as the master blueprint, or the strategic plan. It's a visual flowchart that lays out all the rules, follows the law to the letter, and basically sets up the entire governance structure. It makes sure everything is done by the book every single time, no exceptions.
And then you have the muscle, the algorithm. This is where the rubber meets the road. It's the actual code, written in stuff like VBA or Python, that takes that perfect strategic plan from the logarithm and puts it to work. This is the part that does all the heavy lifting, running the millions of calculations and turning those rules into real, tangible results.
All right, we've got the brain, we've got the muscle. Now let's pop the hood and see what makes this engine run. We're going to get into the specific code and the core formula that makes this whole system not just smart, but 100% audit-proof.
Before I show you the full formula, there's one number you absolutely have to understand: 27%. Now, it might seem random just sitting there, but trust me, it is the golden key that unlocks the entire financial compliance piece of this system. So, what on earth is it? See, not random at all. This is what the research calls a regulatory equation. That 27% acts as a multiplier, a financial bridge that perfectly connects the costs of student engineering projects to South Africa's national R&D tax incentive laws. It's the little piece of math that makes the whole thing legally bulletproof.
And this is the beauty of it all. This is the N-diploma resolution formula, and it is the mathematical heart of the entire system. It's the engine humming away inside the algogram, and every single variable you see here is designed to do one thing: guarantee that a student's qualification and all the money behind it is perfectly balanced and ready for any audit.
So let's just quickly unpack what we're looking at here, because it's actually pretty straightforward. The formula perfectly balances the two most important parts of an engineer's education. You've got T for theory hours, that's all the time spent in the classroom, and PW for practical workbase, that's the documented real-world experience. The system just adds those together and applies that all-important 1.27 multiplier, our 27% bridge, to get a final compliant value. It's a perfect mix of books and boots on the ground.
And when we say theory, we're not kidding. We're talking about the whole shebang. This system is robust enough to manage the budget for an incredibly wide range of engineering topics, from the really abstract stuff like financial regulations all the way down to the nitty-gritty fundamentals of electrical engineering, like exactly how a transformer works.
Okay, so a cool formula is great on paper, but does it actually work? I mean, that's the real question, right?
Let's take a look at the data from the trials and see how this LAS system held up when they put it through its paces.
So let's just walk through one of the actual test cases. This one is for a project to acquire some compulsory land. You can see exactly how it works. The system takes the land and resource costs, adds them up, applies that 1.27 multiplier, and boom, out comes a perfect audit-ready total claim. Simple, clean, and correct.
And what's really impressive here is the variety. They didn't just test one easy scenario. Look at this table. They threw everything at it. Workshop renovations, book productions, setting up labs, even marketing R&D. And every single time, as you can see right there in the status column, the calculation was verified and audit-ready.
But could it handle scale? Could it really perform under pressure? Well, they slammed it with 1,000 simulated financial claims. And the results are kind of nuts. It blasted through all of them in just 1.42 seconds. And the error rate? 0.0. A perfect score. This thing is fast, it's scalable, and it's incredibly robust.
So this is bigger than just one clever piece of software, isn't it? What we're really looking at here is a new philosophy, a new way of thinking about management that the research calls Management 4.0.
And based on these results, the path forward is actually pretty clear, and it comes down to 3 huge steps. 1, standardize the tools so everyone's on the same page. 2, formally integrate that 27% bridge into the financial system for student grants. And 3, and this one is a real game changer, shift the focus of education itself to something called algorithm literacy. The idea is that future engineers shouldn't just solve problems, they need to be able to code the solutions.
This quote just nails it, doesn't it? This isn't about replacing engineers with robots or AI. It's about giving them superpowers. It's about equipping them with an algorithm that does the number crunching flawlessly, 24/7, and a logogram that guarantees every single decision is legally sound. It leaves you wondering, when all the tedious, error-prone work is automated, what incredible new things will human engineers be free to create?